So we look at practice number 13 on the back of the page. Independent. It's in the independent practice section, but I didn't really teach a problem like this. So I'm going to walk you through this one as well. This one is also can be set up as a system of equations, but there's a different way to do mixture problems that's a little bit more efficient than a system of equations. I'd rather you do it the way I'm going to show you this. And basically you're mixing solutions together, different percentage solutions. So if you have something that's weaker than what you want, 5%, and stronger, 15%, because we wanted 12%. So anytime you deal with mixing chemicals and you have different dilutions of these chemicals, if you have something weaker than what you want and mix it with something stronger, you can get a certain amount of each to get an exact percentage of what you're looking for. So as long as it's between 5 and 15, I can do it. 12 is between 5 and 15, so I can do it. All right, so when you see a chemical mixture problem, which the homework will have some of these, this is how you do it. Real simple. You take the weaker, you're going to make little boxes here to represent things. You take the weaker, which is 5%. You're going to mix it with the stronger, which is 15%, in order to get a mixture that is a 12%. So draw boxes representing the mixture that's happening here. We're mixing two different chemicals together. Everything's about salt, 5% salt, 15% salt, 12% salt, so they have to be the same material. Sometimes they'll say 95% water, 5% salt. That 95% water is just in there to see if you think it's important. It isn't. So all the chemicals involve the same thing. All right, 2 weak plus 2 strong equals something in between. Put the percentages above. Now, what I know next, I have to figure out which of these, they're going to tell me one of the three numbers. They're either going to tell me how much 5% we have, how much 15% we have, or how much 12% we have. In this case it says we want to obtain means get 4 liters of 12%, right? So this over here is 4 liters. So now, I'm going to show you the 2 variable setup, but I'm going to change it into a 1 variable setup because it's easier. All right, because I want you to do the easiest way to do this. First off, do we know how many of either of these things we're using? No. No, have no idea. All right, so I'm going to put X here and Y here to start off with. All right, that Y is going to change to something else in a minute, but just start off with X and Y there. Here is the property that's happening here. The percentages are all different, so that varies how much of X and Y you're going to have to use, right? But the overall physical nature of this problem, I pour X liters of one, Y liters of other, I end up with 4 liters. That means these 2 variables, X and Y, have to make 4. Again, I don't know how much salt's involved in each of them, but there's some salt mixture. So I'm pouring in some number of liters of the salt mixture, some liters of the bigger salt mixture. Together, I poured in 4 liters. Maybe it's 1 and 3, maybe it's 2 and 2, maybe it's 3 and 1, maybe it's 1.5 and 2.5. I don't know what it is. But some of this and some of that together makes 4. I know for a fact that X plus Y has to equal 4. Particularly, specifically, this plus this equals this. If you draw your boxes out, just the stuff inside the boxes is what's going to happen to make this equation. If X plus Y equals 4, what does Y equal? If I move the X over there. X plus Y equals 4. Ignore all the 5s, 15s, and 12s. Just look at this.
4 plus X, or 4 minus X.
4 minus X, right? You move the X across, it becomes negative, right? So again, the original setup would be that, but the end result, if you do this little trick here, 4 minus X can go right there. Start with 2 variables. Take everything in the boxes to make an equation to get Y equals or X equals whatever. So you only have 1 variable. Once you get that set up like that, X number, a bunch of percentages, it's very easy to do this problem. All you're going to do is going to multiply the percent times the amount plus percent times amount equals percent times amount. This amount is a binomial, so when you do that, you have to distribute. So it looks like this. 5 times X plus 15 times 4 minus X equals 12 times 4. Percent times amount plus percent times amount equals percent times amount. Then you simplify. Distributed property happens a lot in these problems. So 15 times this, 15 times that. So we're going to get 5x plus 60 minus 15x equals 48. And once again, I've got a couple numerical variables, or terms, I've got a couple variable terms. So both variable terms are on the left. I'm going to keep them there. I'm going to move the 60 over to the right, so minus 60 comes over here. 5x minus 15x is negative 10x. 48 minus 60 is negative 12. Divide both sides by negative 10. We're going to get x equals 1.2. Now our task, we're the pharmacist mixing up these salt solutions. Our task is to know how much of each to use. So x equals 1.2 is the answer for x. What does x represent, going back to the boxes? Where's x located? X is located in the 5% box. So x is how many liters of 5% solution we're using, right? So we're going to get 1.2 liters of 5% salt. And then we're going to have some number of liters of 15% salt as well. And to get that number, this is x in the 5% box. We have 4 minus x in the 15% box. So to get that, I simply have to do 4 minus 1.2. That would be 2.8 liters of 15% salt. So when you're doing chemical mixture problems, you're going to get answers looking like this. This much of this thing, this much of that thing. Don't just give a number answer. Tell me this much unit of this percent of substance. A lot of times they'll do saline solutions. They might do iodine solutions. It could do like an alcohol solution. Pharmacists a lot of times get like antiseptic alcohol stuff, right? So anyway, that's what that is. And again, that's the easiest way to do those problems. Weak plus strong equals in between. Put the numbers where they belong, and then put the variables. And if it just sets it up like that, real simple. There's some relationship between x, y, and the number. Get the relationship, fill the boxes in so they're all the same. Multiply percent times amount to get the answer. Once you get an answer, find the other answer, write your answers down. Pretty straightforward.